How are we doing? Are we almost halfway through the semester?
I don't know where you end up.
Week 7. We're already at the week. This is like the last week in February. It's week 7. So next week we'll be halfway through the semester. The week after that, 7, week 8. What is the week after week 8? Is that spring break?
No, that's the presentation week that you're...
The presentation week that I'm skipping. That's why I need spring break. I'm not going to be here. That's it. I'm like, I think I have to teach you guys one more week and I'll get a break. Who needs a break for you guys? I have no idea at this point. So, okay, so we've got 2 more weeks. We'll have a nice little spring break so you can catch up on all the things that we've been making you do for the last 8 weeks. Before today, what do you guys, how are you feeling? How are you up to this point? Done a lot.
Trying to push the equipment out.
How do you guys are making your assignment much harder than it has to be?
I don't know how much it is.
Probably.
I make such easy assignments, and you guys go so above and beyond. I'm so impressed. So how it is, you guys have assignment 4, so your Kane and your clustering is due tonight. You guys have any questions about assignment 4?
What a question.
Yeah. I'm not going to grade it before midnight, so sure. You can probably turn it at 4 o'clock in the morning if you really want to. I'm not going to be that picky.
I'll hold that to you.
That's
I'll push it off.
Yeah, hopefully I'll get... So you guys leave it well until 15, well, I guess what, until 10 minutes ago, I was all caught up with grading in this class. And you guys finished a quiz. I'm just kidding. I like grading your stuff. Hopefully you guys got some feedback from assignment 3. Faster than usual. Trying. So you can use kind of that feedback as you do assignment 4. Get assignment 4 done. I'll grade that over the weekend. Yay. It's supposed to be kind of snowy and cold and yucky, so it's not going to be good enough to grade. Assignment 4 graded. Your quizzes, for the most part, seem to be looking good. Is this the quiz or is it a bonus question? Ah, bonus question. You're like, I didn't even know there was a bonus question. Yeah, there was a bonus question. You didn't even know it was a bonus question. Surprise! See, I just like doing that sometimes. You're just like, oh, here's questions. It's like, oh, that one. Yeah, so if you missed that question, the one question you weren't sure about, that one made a bonus question. You didn't actually go over it. So, alright. You guys are good. We're going to move on.
Oh, can we like to move on?
Oh, wait, one
More questions. Yes, more questions.
Oh,
Yes.
okay.
No, more. Okay, we're not good. No, we're not good. Okay. More questions.
Okay, first on the K&N.
K&N.
I guess, so I like looked back through what we did in class and then tried to do it again like this. And I guess I'm confused, like what is the PCA actually doing for us? Because I know it's like condensing all of the variables into like 5 different ones.
Your variables, yep.
But I guess when we run the model, like after using the PCA, it says like we now have 18 variables instead of 13. Like it just adds 5 more.
It does,
So,
but
like,
then it's giving the model more to choose from as far as like if you put a variable selection with that, then it might say, ooh, I like these variables better than all of the variables. Your other option would be taking all those continuous, so you start out with 15 variables, you start out with 13 variables, you run the PCA, it gives you 5 more factors. So you could actually go in and say, well, you know what, so if I have these 5 factors, I'd rather use these. And you could go in and you could actually drop the other continuous variables and just use the factors. So that would be an option.
Okay.
Or you can leave it in, yes, there's 18, but it's still going to help choose which ones it wants. So it'll still say which ones are more important. So it will still be able to say, this factor is more important, let's use it. Or it'll say, this other thing is more important, let's use it. So inside your k-nearest neighbor, it's still going to pick the top 3 variables to represent, whether that's just the variable itself or whether that's a factor that's a combination variable.
The top 3 that will be on that graph, basically.
So I mean, it uses more of them in its analysis.
Right, but it's still.
But it's only going to pick the top 3, really. And it'll pick more than 3. Because it'll still match all the neighbors. But it'll still be able to tell you the important variables are either just the row, just the regular variable, or the variable.
And so, like, as far as like the deliverable, if we were to like recommend a model, would it be like these are the top 3 most important, like the number of k?
Yeah, I mean, so the best way to recommend a model is to talk about what are your most important variables, what's the k for your model, and then if you want to, like, a lot of people have been like, well, how do I explain what's happening? An example is the best way that I can say it. So just pick a data point. So like you have your 3D graph.
Yeah.
Pick a data point, and then you're going to be like, okay, so data point number 71. When I select data point 71 and I have a k of 3, then I'll be able to find the 3 nearest neighbors. And you can actually go back, you can either use the chart, this kind of a pure chart that's in SPSS, or you can even go back to the original data and say, oh look, here are these 3, the closest to this guy, and this is kind of what would happen. So you kind of like a little scenario. Would be really the only way that you can explain what's happening with the KNN to someone.
Right.
Practical application, you would have the model somewhere, and then if you're a physician, right, you potentially have, this is this kind of, whatever I'm looking at, heart disease, and I have my little tablet, and I'm going to plug in these different variables, and it's going to pop out, right, so you create a front page that would kind of like say, here are the top 5, the top however many neighbors. This is what you can use to compare your patient to. So that would be the practical, like, actual use of it. Right. There's no equation. So you can't just, like, here's an equation, put it in. So, like, it's actually, we use this term really for a neural network. It's the most common time when you'll hear this. But really, this k-nearest neighbor, what's happening is kind of this black box of what's happening. You really can't trace through and figure out how this happened. We know the idea is it's computing distances.
Sure.
So we can model it, we can do it. But really, as far as from like the analytics person to the end user, there's a black box. So you put in inputs, model does its thing, and it'll give you outputs.
I have the similar difficulty in explaining what K means to a business user. In fact, clustering was a lot easier to explain rather than KNN. So I was trying to find how do I package this, and all probably if I were to talk to an analyst who's probably not going to say that, okay, these are the parameters, fine, that's something that we understand. But how do I?
So here's the difference, right? So you would not be talking to a physician, or you would not be talking to the sales manager on the board, right? Because so we're doing this stuff. They're going to see this. You would have somebody in the middle that would have some, or potentially you guys with all your skills you're learning, right? But you would have this thing in the middle that basically is like you would be selling them or talking to them about this software, or about this program, or about this thing. You enter this in, magic happens, and here's the results you're going to get. You wouldn't actually go through and explain what's happening with this magic. It's not magic, but from the end user perspective, that can kind of be how it's seen. So as far as like what I'm expecting, like from your assignment piece, it really is. So I've tried a bunch of models. I tweaked this. I tried this, and as I tried this, I got this misclassification rate. And then I tried it with the PCA, and I got this misclassification rate. I tried it without a PCA, and I got this misclassification rate. And I tried it with a feature selection, right? So I had all the variables in one of mine, and I only had some variables in the next one, right? So you're just trying different things. You tried it, like I said, with feature selection, without feature selection. Maybe you tried it with, I normalized the data, or I put the data on a 0-1 scale. So the whole idea with data mining, and we'll start to, by the end of the semester, you're like, I really got this. Right now, I'm still trying to convince you that this is an okay thing to do. Okay? But really, as the data mining, you're just, what are all these different options? How can I change them? And as I change them, do I get a better model? So that's why I've kind of been saying like a little table. If we're using ISYS, we can actually do a model comparison. SPSS, you kind of have to make your own little table. This is what I did. This was the outcome I got. And after I did all these things and played with it 5, 6, 7 different ways, this is the best model, and this is what I'm going to talk about. So the thing I'm really going to be looking for is kind of that table of what did you do, how did you do it. And it doesn't have to be in a table. It can be screenshots, it can be whatever. Just a table's an easy way to talk about it. Just kind of stepping me through, I tried these things, this was my best model, and why it's my best model. Does that help?
And similar with clustering, it's kind of also just a trial and error.
It really is just a trial and error.
Yeah, okay.
3 clusters. I can't explain 3 clusters. How about 4 clusters? 4 clusters. I can explain 4 clusters. I'm trying 4 clusters, but I only get 2 clusters. What the heck? Does anybody else have that issue? You guys, yeah, you aren't the only one. There's a couple of my Saturday class that have the same issue. It's not just you.
And on VIA, there's no way to see beyond the 6 variables, right?
So yeah, so so the spline will only do 6.
Okay.
Yeah.
Can we go over how to read that again?
Yeah, can we just pull that up?
Let's just talk. Talk a little more. All right. So today's agenda, just before we go off this slide, right? So we're going to do some little A4. We'll kind of recap what we've done in the past. And then our big thing for today is going to be trees. So we're going to play and make a decision. Where we've been, we're going to skip all that. We know where we've been. We talk about it all the time. So we've hit the 2 things we added were Canaan and its neighbor and cluster. So where we are, where's my slide? There it is. I know I have a slide about this. I want to know. So normally I have these assignments due first and we have a nice big discussion about all this. We can't go quite that far. But these are kind of things I'm interested in. What was your best K? How many clusters did you have and what did you call them? Well, so let's go into VIA. Do you guys want to play along? Or you can just watch? We're going to go into VIA. Let's find a data set. Create a new report. What data set would we like to use? Oh, sure. That's a sneak peek later. What data would we like to use? We got eBay. What data do we have available? Do you guys have more data available now? I'm trying to be adding some stuff.
Yeah, there's like Pelican Store.
Let's try Pelican Store. Do you guys want to try Pelican Stores? We've missed that. Let's see if we can cluster some Pelican Stores. So again, you can play along or you can just watch. Pelican Stores, Razorback Stores. The Razorback Stores had like 1,000 things to cluster. Pelican Stores only has 100. So I'm going to use Pelican Stores. It's a little bit smaller. I think we're going to be able to see some things, and I'm going to be able to teach with it a little bit better. And then we can try Razorback Stores and see what happens now that we have 1,000 points. So first with Pelican Stores, we're just going to be clustering. So if I take my objects, scroll all the way to the bottom, there's a cluster. You guys are all very intimately familiar with this part now. Give me some roles, and since we're clustering and it's unsupervised, I'm going to go ahead and try all the different variables. So when I try these variables, the way that I'm going to see them on my graph is going to be in the exact same order that I have them here. So if I don't like the order I have here, if I want to see them on a different order in the graph, then I can move things around. Like I don't see net cells, but I really think net cells may be important. I can just move them around and it's going to change the visualization here.
explain, last time you said the thicker the line is, there's a significance to it.
Yeah, so the thicker the line, the larger the sample, or the larger the number of clusters. The larger the number in the cluster, the larger the number of observations in the cluster. So if we go through here, so 4 is larger, and you'll see that this has a thicker line. This is kind of where cluster 4 is. So if I just click on cluster 4, the primary line is this thick line right here. So they're low spenders, females, married, they're using our proprietary card, they're promotional customers. Here's if we have 5 different clusters. Expand it a little bit. We can get a cluster. I like the centroid. So the very first thing you see is, so net sales, it looks like we have one group that's really like a higher spender, and then all of these down here are kind of moderate spenders. So that may be a difference in cluster 1. Cluster 1 is going to be my high spenders. Okay, so if I go and look at cluster 1, that's kind of the thing that's a little bit different. We're seeing the higher spenders. Everybody's female, everybody's married, everybody used our proprietary card, everything's promotional. It's not really helping us a whole lot with 4 clusters. So maybe I go back over to my options. I actually have 5 clusters, I apologize, 5 clusters. So maybe I shrink this a little bit. Maybe I just have 4 clusters. Let's see if that makes a difference. So we still have the high spenders. The lower spenders have kind of been put together, but as far as gender, marital status, type of customer, they're all kind of staying the same. And so this is just kind of where you're playing with, maybe I'll try 3.
How do we see the parameter, what's it called? The importance of parameter?
You can't in visual analytics. So this really is, and this is a downside to the visual analytics piece that we're looking at, is it really is more just a visualization of the clusters. So whereas in SPSS, we have like a silhouette value to say how far are things broken apart. Here, we're really just looking at visualizations to see what does it look like, can we explain it, things of that nature. So again, if we were going to spend like a couple of weeks on cluster analysis, which we could do, we dig into all of these different things. For here, my idea was we spent a week on it, and it was to expose you to the idea of cluster analysis, see kind of what's going on, and then hopefully this would kind of give us an idea. So I'm getting smaller, and I'm still keeping the same female, married, and the way our data set's made up, that's not surprising. We have 80% females, we have 90% married. Most of our people are using the proprietary card. So maybe I need to do more. I had 5. Let's see if I do 6, what happens. Not really helping. 7. What I'm hoping I'm going to see is that something here is going to change. That maybe I get a cluster of gender, or maybe I get a different type of customer. That's not really happening. So more clusters really isn't helping me explain what's happening in this data set. Right. The thing that's really changing net sales, so now we have 2 clusters that are higher spenders. But so if gender and marital status and method of payment, if that's really not happening, I'm going to go back to, let's go back to 5, instead of our original one. So we started out and we have one difference is we have a high spender versus kind of our normal spenders. All these other things don't really seem to matter. So maybe age is more important. So I'm going to bring age and put it a little closer. So now we have our high spenders, that's cluster 1. Our in-between spenders. Now we have, I would say, a 60s, a 50s, and then we have our 2 30 groups. So now we have a cluster of our 60s, a cluster of 70s, because it's the average age. And then we have our younger. the bottom, cluster 4 and 5. So now we need to figure out, so we can distinguish cluster 1 by calling them the high spenders. We can distinguish cluster 2 and 3 by calling them the 60s and the 50s. Now how do we distinguish cluster 4 and 5? Right, we need another variable. So I was not smart and I have customer ID in here. Very bad, Dr. Cooper. What happens if I remove customer? Nothing. Well, it changes a little bit. When I remove customer, now I have a cluster where my net sales is higher. So maybe now I have 2. So I have my really big spenders, my big spenders, my moderate spenders, and then my low spenders. Right? So just by removing a variable that doesn't exist, it was trying to cluster based on that. Now we have some better clusters. Still female, married, proprietary, large, everything else. Maybe the number of items is kind of the next thing. So really the thing that seems to be kind of making differences here is our continuous variables. And this is really how, using the visual analytics, how the clustering is working. And you're just kind of trying to mess with the clusters and see if you can explain the clusters. Does it make sense? Here I have 5 clusters. Maybe, let me go back to my options. I didn't try just 2 clusters. When I do 2 clusters, we really cluster it into big spenders and lower spenders. The ages kind of go everywhere in both of them. Our big spenders have more items, which is kind of, right, if we just did 2 clusters, we have a big spender and a lower spender. Is this helping at all?
It's helping, yeah. I didn't realize you could see all that at the bottom.
Yes, so expanding is always fun. So then you have like your cluster summary, and this is like, so if we really started, if you wanted a metric, so we don't have the silhouette value, but if you go to the cluster summary, you can see the average distance, and then you can see the within distance. Right, so here, cluster 1 is clustered more tightly than cluster 2. Right, so our big spenders are more tightly clustered together, and there's only 18 of them. Whereas our lower spenders, we've got 82 of those. That's the majority of our data right there. You can decide, well, if we're just doing, an 80-20 split, that may not be what I want. And that's where you can add in, okay, maybe I really do need 3 clusters.
What is the average distance?
So the average distance is going to be the distance between the centroids of the clusters. Actually, no, wait, let me take that back. That's actually the centroid distance.
The average distance? Wouldn't that be like the average distance of a given point in your cluster from its centroid? Is that outside?
I'm going to go with that. Like, within distance and centroid distance makes sense to me. Average distance, I'm not sure. I'll have to go in and look it up.
The centroid distance is how far they apart they are within the centroid.
So I think the centroid distance should be how far apart the centroids are. So like how far apart the clusters are. Well, I know what I'm looking for. Here we go. This is what I'm looking for. So it's Visual Analytics 8.1. We actually have 8.2, but for the most part, things are going to be the same. So just doing like the little Google, so this is working with clusters, right? So ideally it's kind of showing us, so we're having issues kind of having these pictures fit, and that's just because our data doesn't really support that quite as much. So when you do with more continuous variables, then you can start to see how the clusters relate. Right? So here's cluster 3. It's kind of big right here. Cluster 1 and cluster 2 are pretty much on each other. Right? Sorry. One's the blue one. So cluster 2 and cluster 3 are very close to each other. So there's not a lot of separation. Keep going. Data roles, specifying options. Here it's kind of telling you all the different things you can do. And that's all it is. Let's go about the details table. And it just tells me what it tells me. That is not helpful at all. So more investigation for Dr. But I mean, this is generally how I answer your questions when I come back next week. Is I just go look at the technical stuff and see what else. So my assumption, based on what I've seen in other software, would be that the within distance is generally kind of the spread here. And then the centroid distance should be the distance between the centroids, but I'm not sure what the average is.
So you're saying the width and distance is more like a range as opposed to an average?
I'm thinking it's probably still an average, but it's going to be the average from the centroid. So like it should be, so centroid distance should be centroid to centroid. And then within distance should be the average of a data point from its centroid. So whereas, so if we look, group 3, that's just really hard to visualize here. It should be a little bit more stretched out. It's actually closer and bunched together, so I'm honestly not sure. So basically, anything I've just said in the last 5 minutes, you can really just disregard it and go, Dr. Peter's just really not sure what's happening.
Yeah, like hovering over a point is really confusing.
Yeah. I don't know what you're talking about. It's the net sales. But yeah, when you start to try and get in like here.
Like that makes sense.
Yeah. What I'm guessing is that point is representative of multiple points. Yeah. Because when you hover over just like one single point, yeah.
It did have like a non-integer minus number.
But yeah, the big thing that I'm looking for from you, and I love, and this is what I'm talking about when you guys are like, oh, all the things. I want to understand all the things. All I want you guys to do is look at a pretty picture and kind of name some clusters. All you're saying is, here's the idea of cluster. Look at, mess around with it a little bit, name some clusters. Good to go. But I love that you want to know more. But this is definitely the danger of this class. It's like there's so much you can learn about each one of these topics, and we're doing a topic every week. So, except for this week, because this week, not this week, this topic, ooh, that's how cool decision trees are. Funny fact, they're one of the easiest things to talk about, and we spend the most time on them. Did this help at all?
No, I didn't.
Aside from the 5 minutes of Dr. Keeger doesn't know what she's talking about.
No, that's good.
He's like, this is what it should be. That's not what it is. Alright. But I mean, this is the process of stuff that we go through. It's like, well, I think it should be it. That doesn't make any sense. So what other comments, questions, A4, stuff you need to know for tonight? Yes.
For the Mayor's neighbor,
Painters,
the misclassification rate, there's like 3 different places on the analysis note and the nugget that have percentages of
yes.
correct, wrong,
Yes.
correct or wrong. Which one do we use? Is
So-
it just the one on the graph?
You do not use the misclassification rate inside the nugget. Because inside the nugget is only talking about the training data set. And we don't care. So you're going to go and use the misclassification rate on the evaluation note.
Okay. So then on the evaluation note, not the analysis note?
Sorry, the analysis note. The evaluation note gives you the flip chart.
Right.
Yes. The
Okay,
analysis
so
note.
the analysis note, I'm having trouble. On the tutorials, it says to check the coincidence matrices.
Yes.
Anytime I check that, nothing pops up. But it will work for performance evaluation.
Okay.
So I don't know if that's just, I don't know if anybody else has had that problem.
Yeah, I'm having trouble with it.
Okay.
And again, Saturday people had trouble. So yes. SPSS 2 rescue. And this is the good / bad thing about trying a whole bunch of different softwares, is like there's quirks to all the different software. But whenever you go and get that job, if you do anything like this, the next software you're like, shh, I just learned 4 in 16 weeks. Bring it on. Nothing else. You're learning versatility. And yes, midway through the semester, especially at the end of the semester, you'll have to give me the feedback on, this was good, I liked it, or Dr. Keefer, what were you thinking? Alright, so if we import some data, you guys should all have your data. I'm actually going to, let's see, data that I want. Probably whatever data I have available. What did I do that? Oh, check it out. I even have num01 in there. I know I should probably change some of these, but I'm not going to. I'm going to make sure that my num01's a flag and that it's my target. Make sure that I read my values in. If we really wanted to make this appropriate, I should probably flag that. So I'm assuming you guys have already done all this. Alright, so now I should be caught up pretty good then. Okay, so you have your data set. We partitioned our data set. This 40 thing. Ran a K-Nurse neighbor. I'm going to skip the PCA part for now on. Now, you may have had many steps in between, and that's okay. And the K-Nurse neighbor. Let's just go 3 to 5, that's fine. And so this is where you have the feature selection. You could do it with the feature selection or not. So I'm just going to use the defaults. Got some pictures. then I would attach my analysis node. Check the coincidence matrix, run it. This is what's not happening.
Yeah.
Okay. So some of the things that happen when this doesn't happen is when you're in, so first make sure that it's going straight from your node into an analysis node. The other thing to do to make sure that it comes out, and this is like, and I don't know why this happens, I honestly don't. So coming out of your nugget, I often will put a table and just look and be able to see what's happening. And if for some reason kind of these last three don't exist, and so the last three is like, it's telling you if it's a training or a test, really that may not be your last three. Really these two are your last three, or your last two. So you should be able to see it's just a dollar sign. I can't make it any bigger. It's a dollar sign, and then it should be whatever node you use, whatever model you use, so K and N, and then it should be the variable, your target variable. And so that's like, this is what the model did. And if that's not present, then sometimes that's why it has an issue.
Have it.
So you have that. Then you should have P as well. So same thing. Okay, so you have that. Okay. Troubleshooting. Since multiple ones to be said. Okay, so if you don't click the coincidence matrix, what happens? Do you even get this?
Yes.
Okay, so every time you can get this, does anybody have trouble not being able to get the basic?
Is this the percentage value for this classification?
Yes.
Okay.
So this is for your training, and if you go back and actually look during the K&N node, this should match for your training. But what you're really interested in is your validation, this classification rate. So I don't care so much about the training, this classification rate, because I'm training, I'm playing with that. The validation, this classification rate, is really more what I'm interested in here. Or, if you take the direction prescribed by our textbook, if you add the testing, then you would be interested in the validation of the testing. Either the second or the third. But yeah, so this one was your 83% or your 16% misclassification rate.
And where do we mention this in the same section as?
So this is your modeling section, right? Actually, no, I take that back. This is your evaluation section, right? So your modeling is like, here's what I did. Here's all the output that's basically coming from the nugget. Then your evaluation section is, so I tried this model, and I've got a 16% misclassification rate. And then if I add it on a different node and connected it, and this time I'm going to do the feature selection. There's the output for it, and I'm going to attach analysis node it. So that gives me, in this case, with or without the feature selection, I get the same, right? So here it's 16.28% if I'm looking at, this is my analysis. Let's see if the coincidence matrix makes a difference. Okay, 16.28%, 7 and 14 for, if I try this one, I also have 16.28%. So using the feature selection for this particular data set did make a difference. And then the question comes back to, why can't you necessarily get the coincidence matrix? So if you check that, I'll put you The table thing is generally the one because it. So here, the coincidence matrix is for this non-zero. So a lot of times, what happens is you don't have that value, and that's that big issue, which is why I looked at the table. So if you have that, I'm going to have to dig in and look a little bit more. I don't have that answer out of my head. So during the break, let me see your stuff and we'll look at it. Alright. Yeah, so in this case, feature selection, no feature selection, doesn't matter. Same thing. Other questions from ACE 4 or from last time? Okay. Feeling good? Think we can complete the assignment tonight?
We'll see it. We'll get tomorrow.
It's like, we're going to turn something in tonight, Dr. Cooper. I don't know what it is. You'll have to tell us if it's good or not.
Yes.
We're going to turn something in.
That's where we are at.
Okay. So if I go back to, really quickly, if we actually, am I not logged in? So for in our learning modules, did you guys notice that I opened up some things and I said don't look yet?
Yeah.
Okay, don't look. Okay. So the reason I did that is I've had a few people who are like interested in kind of like seeing what's ahead or seeing some different things. You can look, just don't do anything there yet because like what happened here was this was the original one that I had and I'm using my shell from last year, but I've made updates. This is the one that I just released today. It's the one that you really want. This is where your quiz is. This is where your assignment is. Life is good here. So you can look at these, but you'll notice that they're using your old textbook. The videos are kind of different in different places. That type of thing. Okay? These don't actually work because they're from the spring 2018. So it's there. Yes, you can get in, but don't do any work in there. That being said, the ones that do work, I'm trying to get to the assignment and what I was actually going for. Just to help you make sure expectations are clear. Right, so you've made your new target variable, you've explored your data a little bit. So what we're talking about here, just to make sure, again, kind of expectations, you want to have, so if you did any data cleaning, keep your kind of like, we talked about, a table of what you did for your data, data cleaning. And then I'm looking for just a screenshot of the variables table. So in SPSS, that's that one nice little table. In VIA, may take you a couple of screenshots, but it's just that roles option. And really the idea there is just so I can see, did you classify things the way I expected you to classify them? Did you make a change? Did you actually have the categorical variables as categorical, or did you leave it as continuous? Because just making that slight change will change how it interacts, how the model interacts with your data. Right, so I just want to make sure that if you're getting different answers than what I'm expecting, that's there. For part 9, this is your deployment piece. You guys can just write. I'm not worried about that at all. And here, again, I don't necessarily need all of your node results, but your big, final, best model, that's really what I'm looking for. If you want to give me all and you want to give me a step-by-step, some of you guys, your last assignment was great. And you're going to be able to go back and look at that later and be like, I totally know exactly what I did. If you want to do that, that's great. If you want to kind of put all this stuff in like a table, then that's fine as well. Okay, that's kind of what I'm expecting, is really just what K did you choose and why. With the visual analytics, really your big thing is, I've played around with it a lot, Dr. Huber, and this is what's the best, and here's the clusters that I came up with. All right, so you can change the different and K here is the different number of clusters. You can't really change the distance metrics, so that's something you have to worry about. When I say possibly the component model, that's as if you decide to do SPSS for your choose your own adventure. Then you can play around with this one if you want to, just by going through the tutorial. This is not, if you're doing just VIA, just for task 4, this part doesn't actually apply. That help a little bit. And then, whichever choose your own adventure, only do one, just for fun. If you want to do more, you're welcome to do more, but you only have to do one. That's why you get to choose. You laugh. I had several people. More than one. Not in this class. It was actually a Saturday class. We know how this works. All right. But yeah, I mean, you can kind of see how the points are laid out, where your big things are coming from. The commentary is kind of your big thing. Can you give me the quick explanation of what's happening?
Could you maybe specify a little more like what level of granularity you're expecting for task 4, or are you just wanting kind of like a summary of what we did in total and like discussion of the important parts, or are you wanting like...
Big summary. Hey Dash Keeper, I had a lot of fun playing with this. Here's what came out working the best. You can tell me that I tried, you know, I looked at clusters ranging from 2 to 8. I found that cluster with size 5 worked the best. I can explain that the rest. That's, I mean, I want a very high level. It doesn't need to be, yes.
So follow-up questions. If we did it in SPSS first,
Yes.
the clustering in SPSS tells you like what the best cluster number is.
Yes.
Is that okay to reference saying, hey,
Absolutely.
I did it in SPSS first, and this is what it told me, so that's what I did.
Absolutely.
Okay, great.
Totally fine.
Cool.
Alright. Does that help? Guess any more questions I can help you with? I really am going to start planning for like an hour of, let's catch up from last week. But good, I mean, this is the thing, and this is the thing with, again, comparing last semester to this semester. Last semester, there was an answer. There was a thing. You learned how to do it, you did it, you were done, right? This semester, there's a lot that you can do. It's a lot of playing, it's a lot of figuring out what works best.